Hey, my name's Fernando, and I'm a technical marketing manager here at GitLab. Today I'm going to show you SAST, or Static Application Security Testing. SAST analyzes your static source code for known vulnerabilities. It can detect vulnerabilities like SQL injection, cross-site scripting, and many more. Finding and resolving vulnerabilities is critical to your application's security. SAST also includes secret detection, which detects secrets or credentials which were accidentally committed into your repository. In this video, I'll walk you over the benefits of SAST, as well as how to get SAST configured in your environment. Here's a pipeline which contains SAST, as well as a variety of other security scans. Here I'm running SAST in the test stage, which comes after the build stage. Note this includes secret detection. This is done so that security checks are not run if the container cannot even build. We then deploy to staging, and then run DAST. This is a standard developer workflow running on a feature branch. It ensures that vulnerabilities are detected before the code makes its way to production. Within the merge request, we have a full view of all the vulnerabilities detected in that feature branch. SAST detected that we had an AWS API key checked into our repo. This is part of the secret detection feature. Clicking on the vulnerability displays this pop-up, which includes information about the vulnerability, its severity, as well as where to find it. By clicking on the file, it will take us to the line of code where the vulnerability was detected, showing us the AWS key which was committed. Now let's take a look at a SAST vulnerability. Here we see one for possible binding of all interfaces. The pop-up contains information on where to find the vulnerability, as well as an identifier with a link on how to resolve it. From the pop-up, an issue can be created to keep track of the vulnerability. Here we see the created issue with all the information on the vulnerability. Notice that it is a confidential issue and it cannot be seen by others without access. In this issue, development and security teams can collaborate together on resolving the vulnerability. Within the same pop-up, a developer can dismiss the vulnerability. The developer can add a reason for dismissing it, communicating with the security team as to why it is not applicable. This information, as well as who dismissed it, will be available for the security team to audit. Notice that the vulnerability is crossed out. This shows that it has been dismissed. Merge requests can also contain a list of approvers for vulnerability issues. If a vulnerability with high, critical, or unknown severity is found, someone from this group will be required to approve a merge request before any changes can be committed. Members of this group would usually be members of the security team, but can differ based on your organization. In order to add merge request approvals, you can go to the project settings and see the merge request approval section. Here's where a group of approvers can be added to the vulnerability check. Different rules can also be set up for merge request approvals, such as preventing the author from merging, as well as those who have been contributing code to the merge request. For more information on setting up merge request approvals, see the link in the description. In order to set up SAST, all we need to do is add the SAST template to the GitLab CI.yaml file. We can further configure the SAST template using environment variables. For more information on these environment variables, please see the link in the description. Here are a few things we've learned about SAST. To keep up to date, check out about.gitlab.com and be sure to subscribe. At GitLab, everyone can contribute.